Paradromics and Neuralink, both, I would say, technologically very sophisticated companies, but going about things slightly different ways. The most important difference is the electrodes that are placed in the brain to get close to the neurons, to get within a tenth of a millimeter of the neurons. What are those electrodes made out of? So our electrodes are made of platinum-iridium microwires that are thinner than a human hair. But even though they're very, very small, the material platinum-iridium is stable and will last for a decade after it's placed in the brain.
So let's compare that to Neuralink. What are they? Are they using a different material?
Yeah, they are building, their threads are made of polyamide, which is a polymer. And their electrodes are made of very thin, like less than a micron thick platinum films. And so the reason why they did this is because the electrodes can be made using photolithographic process like you would use for microchips, and potentially made very cheaply and in large numbers. So theoretical advantages of this potentially one day can be used to drive the costs down, and also potentially could lead to really high information density because they can put a lot of electrodes on a single thread that they insert into the brain. In practice, the information density thing has not been realized because in practice, the way that they insert these threads using the robot, they don't achieve the kinds of densities that we're achieving with our electrode arrays, where the electrodes are spaced 300 microns away from each other. So in practice, their first system is 1,000 channels. Our system goes up to 1,684 channels. So we haven't actually hit that break point where they would be pulling more data than our system. But the cost thing is real. I mean, the devices could, I think, be made for a very low cost once they start cranking out. There is a problem with the way that the threads are made, though, which is that those material systems don't last for a long time. Polymers in the body, over time, they absorb water, they swell a little bit, they start to hydrolyze, and it creates interfacial stresses with the metal electrodes that have been, the thin film metal electrodes that are patterned on top. And so in practice, what happens is the probes start to kind of fall apart over time frames of, let's say, 6 to 24 months.
And why do you think they went that route in terms of polymer?
I think the reason is because it lends itself to this vision of a mass-produced device. And in Elon's vision for BCI, he sees BCIs fundamentally as the next cell phone. And so no one keeps their cell phone for more than 2 years. It's sort of a planned obsolescence model. I think in the Neuralink world, everyone's going to want to upgrade their hardware every 2 years anyway. So what's the point? What's the point in building a device that's going to last 10 or 20 years if you're just going to upgrade it in 2 years?
And then, so if we take some of the near term use cases of getting someone to 150 to 200 words per minute, which is a big major focus of paradromics. Ideally, you want it kind of one and done, where it's there for 10 plus years.
Well, that's where I think this sort of difference in philosophy between Neuralink and paradromics becomes really important, is that, if you talk to people who have lost the ability to speak or have lost the ability to move, or maybe are suffering from treatment-resistant depression, talk to people who need a brain-computer interface to meet an unmet medical need, and then you ask them, like, hey, how long would you expect this medical device to last? 10 years is considered the minimum. And most people say, well, I would want it to last forever. And so we just took, like, as a mandate that any technology that we're building needs to last for as long as any other medical device would last, because that's what patients want.
So not to besmirch anything, but so if you had a family member who had ALS, you'd sort of want the Ferrari of the BCI device versus the moped.
Yeah, I think what we've done, which is unique among BCI companies, is we've been able to deliver the Ferrari data rates and also the like Volvo safety levels. There's another difference between our device and the Neuralink device that I haven't talked about yet, which is that our device sits on the surface of the brain. And so when the brain moves, which it does inside of the skull, the device kind of rides the surface of the brain like a boat on the water. The Neuralink device is a little bit different, though. Instead of having the electronics, all the electronics located here in the chest, which we put ours here because that's where pacemakers and deep brain stimulators have their electronics, and it's a very established place to put things. Neuralink has all of their electronics in the skull, and then the threads that I was telling you about reach down into the brain tissue, a bit like tendrils of an octopus. But the thing is that if the brain moves substantially within the skull, there's a risk that as the brain moves away from the skull, the threads can be pulled out. And then since the threads are very flexible, they don't insert back under their own stiffness. And so I don't know exactly what happened in the first trial, but Neuralink reported that 85% of the electrodes that were inserted were like not recording by 3 months in.